Hello everyone, welcome to my channel ECE Scholastic. I am Jasmine. In previous session we have seen how to find the transfer function of a armature controlled DC motor. In today's session we are going to learn how to determine the transfer function of a field controlled DC motor. Okay, so this diagram is same as that of the previous diagram. Only difference here is in the previous diagram we have kept the field as the constant and armature as part as the variable part. But here we are considering only the field part. Therefore, we will be taking the field part as the input and the load part as the output and armature part as constant. Okay, same as that of the armature controlled DC motor, here also we are having two parts. One is the electrical part and the other one is the mechanical part. So obviously we will be writing expressions for electrical part, mechanical part, and also torque is available. So torque we will be considering. Since back EMF is related to armature part, we are not considering the armature part here. Therefore, we can leave this back EMF. Okay, so with the help of electrical, mechanical and torque relations, we are going to find what is the transfer function. So as we know, transfer function is nothing but output by input. Here the output is theta of s and the input is our field part, therefore Vf of s. We need to find what is the expression for theta of s by Vf of s. Okay, for electrical system, the field part we are having an field resistor and field inductor, a field current as well as a field voltage. So what is the voltage expression for RF? That is IFRF. And what is the voltage expression for LF? That is LF into DIF by dt. On applying Kirchhoff's voltage law, we will get the answer as Vf is equal to RF IF plus LF DIF by dt. Okay, I am taking it as equation number 1. Now I am going to consider my mechanical part. So the mechanical part consists of torque, theta, J and B. Correct. So I am going to apply the torque equations with the help of Newton's second law. I will get the expression as J into d square theta by dt square plus B into d theta by dt is equal to T. I am going to consider this as equation number 2. Okay, what is our final part? Our final part is torque. So in the previous session we have seen torque is directly proportional to the armature current, correct? Here we are considering the field part, therefore this is not possible. So we can say torque is directly proportional to the field current because armature part is equal to constant, correct? So on applying the formula we will get torque is proportional to IF. In order to remove the proportionality, I am taking a constant KTF. Therefore, T is equal to KTF IF is my third equation. Similar to the previous section, we are going to take Laplace transform for all the three equations we obtained. So, on taking Laplace transform for the first equation, we will get IF of S RF plus LF S IF of S is equal to Vf of S. And for second equation, we will get the same answer. And for third equation, we will get the answer as T of S is equal to KTF IF of S. So, I am going to take this as equation 4, 5 and 6. Okay. Now, on comparing fifth equation and sixth equation, I can say T of S is there. So, we can combine these two expressions, correct? Therefore, we will get J square theta of S plus Bs theta of S is equal to KTF IF of S. So from this I am going to take theta of S as a common factor. I will get this expression. From this equation I am going to find what is IF of S. So I will get the expression for IF of S as this. Okay. Similarly from fourth equation I will take IF of S as a common factor outside and I will rewrite the expression. So in this expression I am going to apply the value of IF of S as this. So I will get an expression as Js square plus Bs into theta of S divided by KTF into RF plus L of S is equal to Vf of S. Okay. So what is my aim? My aim is to find transfer function. What is transfer function? Theta of S divided by Vf of S. With the help of this expression, I am going to find the required transfer function, that is theta of S divided by Vf of S is equal to KTF divided by S into Js plus B into RF plus L of S. I am taking this as equation number 8. So what will we do next? Obviously we will be writing the transfer function equation with respect to the time constants. So in order to represent in time constants, from first expression I have taken R of S as a common factor, and from the second expression I have taken B as a common factor. So here writing this as TF and J by B I will be writing this as Tm. KTF divided by R of BF I will be replacing that as K. So from this I can say that LF by RF is equal to TF, which is field time constant, J by B is equal to Tm, which is mechanical time constant, and Km is equal to KTF by RFB, that is motor gain constant. Understood? So with this, the transfer function of field control DC motor is over. Thank you for the patience. For queries, please mail me. Don't forget to like, share and subscribe.